Imagine a planet where the wind never stops, where it screams across the surface at speeds that make a hurricane look like a gentle breeze, where the sky itself is made of something that should not be able to fly. Glass. Silicate glass particles hurled sideways at 5,000 miles per hour, not falling, not drifting, firing, like bullets. In every direction. All the time, this place is real. It exists right now, about 63 light-years from Earth. And the question that haunted astronomers when they first studied it is the same one we need to answer today. How does a planet get this bad? And what does it tell us about just how strange the universe is willing to get? The planet is called HD 1897333b, not the most poetic name, but what it lacks in poetry it makes up for in sheer terror. From a distance, it looks almost beautiful. A deep, vivid blue, the kind of blue that makes you think of Earth, of oceans, of somewhere livable. That instinct is wrong. HD 1897333b is what astronomers call a hot Jupiter, a gas giant, roughly the size of Jupiter, but sitting extraordinarily close to its host star. To give you a sense of scale, Mercury, our innermost planet, orbits the Sun at about 36 million miles. This planet orbits its star at a tiny fraction of that distance. It completes one full orbit in just 2.2 days. It is so close to its star that it is almost certainly tidally locked. One side permanently facing the star. One side permanently facing the dark. On the day side, temperatures reach over 1,000 degrees Celsius. On the night side, it plunges to something far colder. That temperature difference between one face of a planet and the other is what drives everything. The wind, the chaos, the glass. When we see a blue planet, our brains do something automatic. We assume water. We assume atmosphere. We assume something familiar. But the blue on HD 1897333b has nothing to do with water. It comes from the way light scatters off tiny particles of silicate in the atmosphere. Silicate is, essentially, glass, the same material in your window, in sand on a beach. Except here, those particles are suspended in an atmosphere hot enough to keep them permanently airborne. They never settle. There is no ground to settle onto, not one you could stand on anyway. It is a gas giant wrapped in a permanent, scalding fog of microscopic glass. And that fog does not sit still. The fastest wind speed ever recorded on Earth was 253 miles per hour. That was during Tropical Cyclone Olivia in 1996. It destroyed everything in its path. On HD 1897333b, the wind speed is estimated at around 5,000 miles per hour. A commercial jet flies at roughly 500 miles per hour. The wind on this planet moves 10 times faster than that, continuously, across the entire planet. And those winds are not carrying water droplets or dust. They are carrying glass. Silicate particles swept up from the upper atmosphere and launched sideways at speeds that make a rifle bullet look slow. This is not a storm. This is the permanent state of the planet. There is no calm before this particular storm. There is no calm, ever. The reason the wind reaches these extremes comes back to that temperature difference. The day side is being blasted by a star from just 3 million miles away. The night side is comparatively freezing. That contrast creates an enormous pressure gradient, and nature, as it always does, tries to equalize it. Air rushes from high pressure to low. But on a planet this extreme, with no landmass to break the flow and no slow seasonal cycles to moderate it, the wind just builds and builds until it is moving at speeds that belong in a physics thought experiment, not on an actual world. On Earth, rain is water. It forms when water vapor cools, condenses into droplets, and falls. Simple, familiar. On HD 1897333b, the same basic process happens, but the ingredient is completely different. Instead of water vapor, you have vaporized silicates high in the atmosphere. As those silicates move towards slightly cooler regions of the atmosphere, they condense. They form tiny solid particles, and then the wind catches them. The word rain is almost misleading. These particles do not fall gently. They are flung, horizontally, at 5,000 miles per hour. The geometry of this planet means there is no quiet downward drift. There is only the wind. Think of a sandstorm, but instead of sand, it is glass. And instead of 40 miles per hour, the sandstorm is moving 100 times faster, and it covers the entire planet. All of it. All the time. There is nowhere on this planet that is not inside that storm. Here is the part that still amazes me. We have never sent anything to HD 1897333b. We cannot see its surface directly. It is 63 light-years away. Everything we know comes from light. When the planet passes in front of its star, a tiny fraction of the starlight filters through its atmosphere before reaching us. Different molecules absorb different wavelengths. By studying which wavelengths dip, astronomers can figure out what the atmosphere is made of. This technique is called transmission spectroscopy, and it revealed the silicate particles. It revealed the temperature. Combined with Doppler measurements and atmospheric models, scientists estimated the wind speeds. Essentially, we are reading the chemical fingerprint of a storm on a planet 63 light-years away, using only the light that squeezes around it for a few hours every 2 days. That is one of the most remarkable things human beings have ever worked out. HD 1897333b is not unique in being extreme. The universe is full of extreme places. But it matters for a specific reason. It was one of the first exoplanets to have its atmosphere directly characterized. Before this, we could detect exoplanets. We could measure their size and mass. But reading the actual chemistry of an alien atmosphere was new territory. Today, telescopes like the James Webb Space Telescope are pushing this further, studying dozens of exoplanet atmospheres, looking for water vapor, carbon dioxide, methane, the signatures that might one day point to biology somewhere out there. HD 1897333b is a landmark, not because it is habitable, it is spectacularly not habitable, but because it proved we could do this, that we could look at a planet dozens of light-years away and say, with real evidence, what its sky is made of. A sky made of glass moving faster than sound. But still, we could read it, so how does a planet get this bad? It starts with proximity. Too close to its star, with no moderation, no seasons, no relief. The day side cooks. The night side freezes. The difference between them generates wind on a scale that has no comparison on Earth. That wind picks up silicates from the upper atmosphere, tiny particles of glass, and throws them sideways at 5,000 miles per hour. Continuously, permanently. The blue color is not hope. It is a warning. And the reason we know this, the reason we can sit here and describe the weather on a planet in another solar system, is because of what starlight tells us when we know how to listen. 63 light-years away, right now, glass is moving faster than anything you have ever seen. The storm has been raging for billions of years. It will rage for billions more. And somehow, from this small, quiet planet of ours, we figured that out. If you want to keep exploring places the universe really should not have built but did anyway, subscribe, because next time we are going to a place where it rains iron. Not glass, iron, and it is somehow even stranger than this.